Hi and welcome to today's video. Today I'm going to go through the entire installation process for the Arduino IDE and show you pretty much what I know about Marlin's Config.h file. So we're going to start off by showing you what to download, what you need to do, and what the changes in Config.h do. So let's just get straight into it. So the first thing we want to do is download the Arduino IDE. I've just jumped onto Google and searched for Arduino. You can use any search engine, just search Arduino. This is not an advertisement for Google. And what you're looking for in the results is www.arduino.cc. So in this case, it's the very first one. I'm just going to click that. And then the Arduino homepage pops up. We don't want to buy an Arduino at this point. We just want the software. So we click the software button. And they've introduced a new online IDE. I don't want to use that, so if you get a little bit confused by this, just scroll down a little, and then it says download the Arduino IDE. This is the section of the page we want, and at the time of this video, it's Arduino 1.8.1. That's pretty important because this version, you don't have to mess about getting libraries and stuff installed. It just works really nicely. So what I'm going to do is I'm going to click Windows Installer, and I'm going to click just download. You can contribute to Arduino's cause if you feel you need to. Contribution is a good thing, but I'm just going to click just download and I'm going to hit save. Now, there is an IDE for Linux and Mac users. You just have to select which one you want. And depending on your internet speed, it'll download in a few seconds. So this is now downloaded. So I'm going to open my downloads folder. And I'm going to get rid of Google because I don't need it anymore. And we have an installer. So I'm just going to double click that. And then the Windows User Access Control is really handy because it says, do you want this app to make changes to your device? Yeah, thanks. And then we're offered a license agreement. I'll just get rid of the download folder so you can see that. Basically, you click agree because if you don't, it doesn't install properly. And now you get a bunch of options. Now, I don't like the start menu in Windows 10, so I untick create start menu folder, but you need to leave install USB drivers installed and associate.ino files, because if you don't, then you have to mess about a bit. So that's it. Click next. Where do you want to install it? It defaults to C programs, but I don't like using C programs. I much prefer to use the D drive because I've got one. So I'm going to do that and I'm going to hit install. And after a short time, it will install. So I'll probably accelerate this part of the video. There we go. So now that it's finished, you can just click this close button. And that's it, nothing happens. So what you've got now on my desktop, I've got an Arduino shortcut. Right, after a quick restart, what we're going to do now is we're going to go to the Dropbox folder where the Marlin firmware is, for the eBay Prusa i3. That's the one I'm going to use because it's the one I've been messing about with the most. And what you'll find is there's a folder called Marlin. It has to exist inside a folder called Marlin. If it doesn't, the wheels fall off, and it doesn't go anywhere. So we're going to double click Marlin folder. We're going to scroll down, and what we're looking for is marlin.ino. Now, if you don't have the extensions enabled on your system, you just look for this kind of like round blue icon. That's the one you want. You just double click that. And what will happen is it'll boot up the Arduino IDE and it'll show us the Marlin interface. The Marlin interface? No, it'll show us the IDE. It shows us Marlin within the IDE. It's early. Right, okay, so here's Marlin. And what you'll find is that the text is really hard to read. I don't know how you change the color of the text in the IDE. I haven't figured that out yet. But what we want is on these tabs across the top, we're looking for Config.h or Configuration.h. And when we click it, it doesn't look like much happens because the header at the top of all the pages is the same, but you'll notice down here changes a little. So what I'm going to do, if you notice somewhere on the screen, down here at the left hand side, it has the line number. So if you're following along with this version of Marlin, which I'll put a link in the description to my Dropbox so you can get the exact version, you can follow along with the exact line numbers that I'm talking about. So there's nothing else to say. We're just going to have to dive into it. I know it's a bit scary, but we're just going to have to jump in. So I'm going to scroll down. Now, there's some kind of advanced configuration.h that I don't use but I have seen a few videos on it, and it's got some pretty good things, and I'm not going to cover that in this video. So we're just going to keep scrolling down, and we'll see the config.h version is 010100. I don't know if that's binary or somebody just hasn't put the decimal places in, but not to worry. And there's a get started. There's a whole load of links to the internet. You can click these. They are kind of hyperlinks. There's information about Delta printers and all sorts of stuff. And then we start getting into the text, which is kind of like black or bold, and the word #define. And people kind of like start freaking out when they look at this. Don't worry about it. It's easy. Now, any text that starts // is purely a comment for you to read to try and understand what this means. And anything that starts #define is part of the programming language, so you need to get the syntax right if you're going to mess with it. But we'll cover all that in a sec. So we're going to keep scrolling down. So what it says here is about serial ports. Now, I just leave that defaulted to 0 because we use USB anyway. I don't really know why you'd want to change it unless you're using a Wi-Fi adapter, which is doing a serial port emulation stuff. But I only ever run my printer off the SD card or off the USB connection. So just leave that to 0. Now, the next one is baud rate. Now, this is quite important because what you're doing is you're telling your control board of your printer that the baud rate is a fixed number. Now, if you're like me, you use Repetier Host, you have to go into the settings of Repetier Host and set the baud rate to the same number that's in here. Like we're using 250,000. So if I go into Repetier Host and I set that to something different, it's not going to talk to the board properly. So you have to get these numbers to match. I wouldn't advise changing it from 250,000, but if you're having difficulty connecting to your printer, look in the firmware in the config.h to see what the baud rate is, and then set your Cura or whatever to the same baud rate. Now, the next section is about motherboards. This bugged me for a long time because, as you can see, this is using a board_Ultimaker, and I have no idea what this eBay printer board is. It's just a clone of a clone. So I honestly thought it was a Mega with a ramps, and I got massive problems trying to get it configured. So I had to change it to board_Ultimaker. Now, if you're trying to upgrade from an older version of Marlin, you can look through the config.h of that version and just put the relevant information into this config.h file. There's more information in this config.h file, but we just skip it because we don't know what it is, we don't use it, and by default it's turned off. So the motherboard, defining the motherboard is pretty important. Now, if we go to the drop down over here and we scroll down, there is somewhere in this huge list something where you can pick the board. Right, that was pins. I didn't want that. Go back to config.h. Oh, come on. Right, we'll just scroll back up because it's probably under boards. That would make sense, wouldn't it, really? There it is, boards.h. Now, if we click boards.h, what it does is it just lists all of the boards that are compatible. And if you want to change to a different boards, like a ramps 1.4, and it'll tell you all kind of stuff here, you just copy that entire string of text there and paste it in to config.h right here. So you can switch which board you want. Right, you can have a custom 3D printer name in this version of Marlin, which is really cool. When you power your printer up, it gives you like the flash screen, and then it'll say 3D printer ready, because I've written the words 3D printer in there. If you want to call it Frankenbot or whatever the hell you want to call it, you can put it in this area. Don't put too many characters in, because what will happen is it'll fill the bottom line and then it'll jump to the top and it'll say ready and it'll obliterate the text at the top. So you've got to be a little careful. Now under this we get into the kind of the meat and veg of it. So this is the number of extruders you've got. If you are building a multi-extruder thing, you just change that number to 1 to 4. We've got 1 extruder. If you've got a switching nozzle, what the hell's a switching nozzle? You would mess with this, but I don't mess with that because I don't have one. And as you can see here, this line here where it says define switching extruder, it has 2 forward slashes in front of it, which disables it completely. If you had a switching extruder, you would simply delete the 2 forward slashes and then all of this piece of code would be enabled. We're going to leave that disabled. Now, underneath we have a mixing extruder. Again, 2 forward slashes, it's disabled. I don't know. And further down, we have the type of power supply. If you're using an ATX power supply, you set power supply to 1. That's any kind of power supply that isn't an Xbox 360 power supply. If you're using an Xbox 360 power supply, you set that to 2. And I imagine with the Xbox One being out now, quite a lot of people will use the 360 power supply because it's quite powerful and it's readily available. Right, now that we've done with that nausea, we're looking at the thermal settings. So when people say, I want to change this hot end to an E3D V6 and I've got to change the thermistor table, how do I do that? Well, what you do is you look at this section of the config.h file. And what this is all the thermistor numbers. So when they say set the thermistor number to 5, this is thermistor number 5 here. It's a 100K Semitech ATC, blah, 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 blah. And where you put that in, is it down here where it says hash define temperature sensor 0? Yeah, I know, temperature sensor 0. It's for the extruder, which is the first extruder. Programmers, I don't get it. But yeah, temperature sensor 0. And I've set that to thermistor number 5 because I'm using an E3D Light 6 hot end in this. Now, also, on your heater bed, you have a temperature sensor in that. And I've used 1. We'll go back up. 1 is 100K. Best choice for EPCOS 100K with a 4.7K pull-up resistor. I wired in a thermistor I got from eBay, which says it was a 100K for EPCOS equivalent thing, and I set that to 1, and it seemed to give pretty reasonable results. The way you test this is if you turn your printer on and the hot end is reading from cold and the hot end is reading one temperature and the bed is reading a different temperature, there's some kind of problem, because they should both read the same temperature, because obviously the temperature in the room is going to be fixed, and from cold your printer should both read the same temperatures. If they read something different, you need to mess with this. Now, excellent. What we've got here is a whole load of settings that I don't know what they are, and I haven't messed with them, but there's text above them if you want to read all about what they do. I believe they're safety settings, so that if the temperature doesn't change for a while and it's demanding power, it just shuts down. But I don't know. Don't take that as gospel. I don't know what these settings do. This version of Marlin's pretty new to me, so I just mess with the bits that I mess with. Anyway, so we've got temperature redundant time and we've got bed redundancy and stuff like that. You can look into that and see what it is. If you want to mess with it, it's all there. I'll leave all that as default. Now, we've all turned on our 3D printer at some point and had MinTemp. Now, this is usually because the temperature of the hot end or the bed is too cold. But it can't be too cold because it's ridiculous. Now, this part of the code basically tells you what the minimum temperature you want your printer to be is. By default, it's usually about 5 degrees C. Now, it gets pretty cold in this room. So what I did was I reduced that to 2 degrees C so that I can turn the printer on, and as long as it's above 2 degrees C at the hot end of the bed, you don't get the MinTemp error. You can feel free to mess with that and like set it to 20, upload it to the printer, and then when you turn it on, if it's 15 degrees, you'll see the MinTemp error. So you can understand what that does. Likewise is the max temp setting. Hang on. Oh, God. The max temp setting. Now, this is handy if you've got a PTFE lined hot end, because obviously if your hot end's PTFE lined, you don't want to go above 250, 255 degrees C. So if you can set in config.h the maximum temperature, and what will happen is, if you send G-code to the printer to say heat the hot end up to 400 degrees C, it'll get to 255 in this case, and then it'll give you max temp and it'll stop. Same with the bed. I don't want the glass to get any hotter than 150, mainly because I don't want my house to burn down. So if it tries to do something ridiculously stupid, say the controller goes faulty and it just outputs power to the bed, as soon as the thermistor reads 150, it's just going to shut down. So they're pretty good settings. Okay, so this is the next section, PID settings. Now, what that is the numbers which control the PID loop, which power up the hot end. So basically, it should be turned on or turned off, and as it approaches the target temperature, it cuts back on the amount of power. You can auto-tune this. Tom put a brilliant video up about auto-tuning. I'll put a link in the description, and in that video he'll tell you to use the PID numbers in the firmware. Now this is where you put them. So what I did was I created a / E3D Light 6 section, and I just put them numbers in, and I made sure everything else had 2 / in front of it so that it wasn't used. If you have an E3D Light 6 or a V6 or a Volcano, I am assured by E3D that the PID for one works on all of them because the mass of the heater block is roughly the same. So you can go ahead and use these numbers as your PID. I find they work great. You know, it heats up, it gets to the target temperature, it doesn't kind of like wave around the target temperature too long before it starts to print. Likewise is the PID for the bed control. Now, here on line 322, we have define PID temp bed. You can put 2 / in that, and you can switch that off completely, so it'll just put power to the bed and then none. I like to run PID because it keeps everything a little more stable and it uses a little less power. I've got a 12 volt PCB heater on 4mm borosilicate glass, so I added this section of the code and made sure everything else was // commented out. And likewise, if you want to use the same as me with the 12 volt PCB heater, you can put these PID numbers in for your bed and you'll have no problems at all. Right, so now what we're going to do is we're going to go down and we're going to skip quite a lot of this stuff because, you know, I've just spotted something I want to talk about actually. So I'll skip down in a sec. This line here, Extrude MinTemp, we've all done it. We've all tried to extrude something when the printer is not hot. The hot end is not up to temperature. This number here tells you what the minimum temperature of the hot end is before the extruder motor will actually turn. So it stops you from getting like filament jams and stuff. If you find that you print PLA and you print it at 190 and it's liquefied too much, you can drop this Extrude MinTemp down to 150 and then you can start to extrude at like 180, 170. Because if you try and extrude at 170 and the min temp is 170, as the temperature fluctuates between 169 and 171, you'll get intermittent extrusion. So you can fix that here. That's line 367. Right. Now the next section here is the thermal runaway protection. That's all turned on this one. I have no idea what it does. I haven't messed with it, but it sounds like it's important, so I wouldn't mess with it. We've got mechanical settings. So if you're building a Core XY thing, or a Core XZ, or a Core ZY thing, you need to uncomment out these bits. But if you've just got a bog standard Cartesian setup, you know, 1 motor for X, 1 motor for Y, and maybe 1 or 2 motors for Z, just leave all that commented out, it's fine. End stops, gotta love end stops. If you don't have end stops, your printer doesn't know where it is, trust us. So this tells you all about how your end stops work. Now, this first section is about homing. So it's which end stops do you expect to trigger when you press home. Some printers go to max, some printers go to min on X, Y, and Z, and these basically just say which plug is it expecting to trigger when it homes. We can disable end stop pull-ups for reasons. If your board doesn't have end stop pull-up resistors fitted, you can enable this or you can disable it. I've never ever messed with that on any of the printers that I've got, with a Ramps board or with any of the clone boards. Just leave it well alone, it's fine. Now this next section is a little important because if you're using microswitches, they give out a high signal when triggered. So when the carriage comes along and hits the microswitch, it gives out a high signal. The rest of the time it gives out a low signal. If you find that your printer doesn't do anything when you press home, it's probably because the signals are inverted. Now, you can do some pretty weird stuff to the mechanics of it and solder the wires the other way around. Or you can just say it's the x-axis. You can just change that false to true. And what will happen then is it will invert the signal for you. So you can do that with any end stop. You can also do it with a Zed Probe if you've got a Zed Probe fitted and you find that it's triggering the wrong side. You can just change that from false to true. All of this stuff now is about the Zed Probe. I don't use a Zed Probe. I've never used a Zed Probe. I'd like to try one, get it working, but it's all settings to do with the Zed Probe. So we're just going to skip right past all that. There's quite a lot about it. There's the Zed Probe offsets. There's all sorts of stuff in here. You know, and we can disable X, Y, and Z when you're using the Z, obviously. But yeah, we're just going to skip straight past all that stuff. Right, now what we're going to do is we're going to talk about the X direction, the Y direction, and the Z direction. And I know, if your X direction goes the wrong way, you can just unplug the stepper motor and turn the plug round and plug it back in and it goes the right way. I know. But if you've got a printer with one of these clone boards on and it's got them stupid keyed connections so you can't turn it round and put it in the other way, and you don't want to cut the wires and resolder them, this is where you change the direction of the printer. So if it's the X direction, you just change the false to true, the true to false for the Y, and the false to true for Z. You don't have to mess about changing plugs around and all that stuff. Just change them values. The same can be said for the extruder. Now this is a one that I get asked quite a lot, because obviously if you buy a different extruder, you've got the motor shaft here and the knurled cog there, and you put another extruder on, it might be over here. So your extruder needs to go backwards now. So again, invert extruder 0, which is the first extruder. Mine's set to false. If it's going the wrong way, you can set it to true. Or you can mess about with the wiring, turn the plug. You know, you can do it all in software. Just do it in software. It's easier. Likewise with the homing direction, we've set above which end stops we expect to trigger when we home. So we can now say we want the home direction to be -X. So it's -1. It goes in the negative direction. -Y and -Z. If you want to home your printer the other way, you can just take out the minuses and do 1, 1, 1, and it'll go the other way and it'll trigger the max. But you have to go back and tell the thing that you're expecting to trigger the max end stops. So you might have to mess about with that a bit. Travel limits are another good one to set. So if you've got a bed which is a strange size, and you find that the printer doesn't move far enough, or it moves too far and hits the end, you can set the travel limits here. I set mine to X180, Y193, and Z180. You can probably mess with the mechanics and push things out, but I find that works great. I don't get any collisions. And if the G code goes crazy and sends a move to X250, it'll get to X180 and stop because the firmware says it can only move to 180. And that's it. Right, this is about filament runout sensors and mesh bed leveling. I don't know what that is. Auto bed leveling. Now, this is something that a lot of people believe in. This is something that I've never used. I've never tried to set it up. I actually prefer to mechanically adjust the level of the bed with, tools. That's just the way I am. If you want to mess with this, there'll be loads of stuff. But if you want to turn on auto bed leveling, like I say, delete that comment line there, them 2 forward slashes, and then continue to mess with all of this stuff. There's a whole load of stuff about auto bed leveling there. Right, so we've got additional features here, which means we can use M500, M501, and M502 at the command line to send EEPROM commands to it. I don't do that. I use the IDE and I flash the EEPROM. It makes it much easier, because I find if you start using M500, 501, or 502, then you get a little confused as to what the printer's got on it and what the software has recorded in Config.h. You'll have some mismatches. If you want to do that, you go for it. If you don't. But again, you would have to take out those comments to enable that. Right, so we've probably all worked our way through the menu in Marlin, and we've discovered that we have a preheat setting for ABS and a preheat setting for PLA. And this is where you change what they are. If you look at it and think, well, that's stupid, I don't print PLA at 190, I print PLA at 210, and I don't print the bed at 50, I print the bed at 40. You can change these here these values for your two preheat settings actually within the menu. If you don't want to mess with it, don't mess with it. If you don't use it, don't use it. It's fine, but that's where you change it. So scrolling a bit further down, I have no idea what that is. That's a nozzle park position. Oh yeah, this is for nozzle cleaning. Now, you've probably seen those awesome Lulzbot printers, like the Lulzbot Mini. They have like a felt strip, and before the print starts, it kind of like moves and it zigzags up the felt strip and scrubs the nozzle clean. If you wanted to put that in your printer, this is where you set it up. I haven't messed with it. I don't know how to do it, but that's where you set it all up. It looks like it could be pretty good. If I could set it up and I had a printer that was big enough to have this spare space, because obviously you need some non-printable area to set all this stuff up, that'd be quite nice. But I haven't done it. If you want to mess with it there. So, LCD supports. Have we skipped something here? I think we have. Not to worry. Right, anyway, we'll go back in a sec. The LCD support. So, if your LCD doesn't work or it displays bizarre characters, and at the very, very start of the Config.h, you've got the correct board set up, this is where you mess with it. So, we've got define Ultra LCD, because up here it says you may choose Ultra LCD if you have an LCD with a 16:2, 16:4, 20:2, 20:4 character set. If you're not using that, you change it to something else, but Ultra LCD is fine. If you're using Dog LCD, it's for the full graphic display, so the one that has the little graphic of the fan that spins around, you change it there. If you've got an SD card reader, you need to define SD card support by just deleting the comments here. I think by default they're commented out, so I had to delete the comments there. And then the rest of it, you can just leave that all commented out because you don't want to mess with the SD card speed. Unless your board is pants and it doesn't read the card fast enough, you can then half or quarter the speed of the SD card data. I don't have to do that. I don't think these days SD cards need to do that. You can get ultra high speed ones. Not that you need them. The files are huge. They aren't huge. So that's it. Everything else under here is commented out. I don't use it. The rotary encoder. This is a good one. I like this one. A lot of people say the rotary encoder, you turn it one way and you go down. But when I upload the new version, you turn it the other way and you go down. So strange enough, this says define reverse menu direction. So if you find it's going the wrong way, just delete that comment and it'll go the right way as to what you want. That's on line 1051. Yeah, we've worked our way quite along. This is a long video, I'm sorry. But we're nearly there. If you want a speaker or a buzzer, you can define it here. If you need to mess with your LCD backlight and stuff, you can define it there. And then as we go down here, it lists all of the different panels. I'm using a RepRap discount smart controller, which is line 1139, and you literally just take out the two forward slashes to activate that. If you're using a G3D panel, you would comment this one out and delete them comments there, and so on for anything that says #define with the controller. There's the full graphic controller. So if you're using Dog LCD, and you would have to uncomment that and comment this one out. And as we go further down, it's all about LCDs. Now, there's some stuff at the bottom for extra features. I have no idea what they are. I don't mess with them. And that's it. There's servo controls and all sorts of stuff. But I have missed a very important one. I'm going to go back up because in this version of Marlin, I don't know where it is. It's so easy to miss, as you can tell, because I missed it. But it's very important that you set this correctly. And it is... Where is it? There it is. There it is right there. I don't know how I missed it. It's just above additional features. The line we're talking about is line 763. And you're right, it's steps per unit. For some reason it says for Ultimaker at the end. I don't know why. But this is how you read the steps per millimeter. And this is how you modify it. All of this other stuff underneath, you can use my settings if you like. I find they work great. It's the acceleration, the retract, the jerk, and all that kind of stuff. I've never messed with it really because I've never thought a problem too. But I do know that if you have oscillation and you get like weird wavy lines in your print, you can mess with the jerk settings and the acceleration to fix that. But I've never been that bothered about it. This line here is the one we want to talk about. Default axis steps per unit. Now, in these curly brackets, you have 4 numbers. And there's no explanation about these numbers at all. But what they mean is number of steps per unit for X, Y, Z, and the extruder. So what I'll do is I'll link another video of Tom's in the description about how to tune your steps per millimeter for the extruder. And then when he says, this is the number that you put in the firmware, this is the number here that you use. It's X, Y, Z extruder. What you find is, if you're using toothed belts, X and Y are the same because the pitch of the belt is the same and the drive wheels are all the same diameter of X and Y. Z is controlled by whatever the hell size threaded rod you're using. Some use M5, some use M8, some use weird ball screw things and stuff. So you would have to really kind of like mess with that to tune it up. But if you watch Tom's video on how to tune the extruder, what it does is it basically teaches you how to demand a certain length of extrusion or a certain length of movement, measure it, and if you've got a different length, how you use the number you've got already to calculate with the movement what the new number should be. I'm using a Mark 8 all metal extruder, and strangely enough, 100 steps per millimeter is just about right for me. That is probably one of the most important ones, and I don't know why anybody hasn't put like a huge commented section at the top here to say this is what this does and this is how you read these numbers, because there's pretty much nothing here. I mean, down here on the acceleration it says XYZE maximum start speeds. If it just said XYZE default steps per millimeter, you would understand that a bit more. But that's pretty much everything you need to know. Well, it's not everything you need to know. It's everything I know about Config.h. So now it's everything you know about Config.h. If you want to know anything more, I can't tell you anything more about it because this is everything I know. So let's say that we've got everything sorted out in our Config.h file and we're going to do an upload. It's very simple. What you do is you go to Tools, you go to Board, and this is going to be an Arduino Genuino Mega 256. You make sure the processor is on at Mega 256, and when you plug your printer in, you'll get a COM port here. Don't use COM1, that won't be right. You'll get a COM port appears here. You'll click on it, and then what you do is you literally just hit this arrow here which says upload, and that will upload your firmware to your printer. You'll get a progress bar at the bottom right here. It takes about 2 or 3 minutes to upload. Your printer will restart, and that'll be it. Then you can test your settings, mess with it, do whatever you want, change it, and upload again. When you press this tick button to verify or this arrow button to upload, it automatically saves whatever you've done to config.h, so you don't need to keep going in and clicking file save. So I think that's pretty much everything. Yeah, I think that's it. So what I'm going to do is, because YouTube's been a bit weird about the subscribe button and the little bell thing, and it's really annoying us, what I'm going to do is I'm going to completely change the outro of the video, and I'm going to say, that's it for now. As usual, I've been Steve. Thanks for listening.